Hi YouTube, I think Hyper Demon is one of the coolest looking games out there. When I saw the Unrecord trailer, I was instantly reminded of Hyper Demon, and I found a thing these games have in common, a fisheye effect. This inspired me to try and create my own, so that's what we're going to do today. So what is a fisheye effect really? Things are like distorted based on the distance from the center of the screen, like FOV but not flat. So what differentiates it from the FOV? Let's have a closer look at the view frustum. You will notice that the frustum far plane is flat. That's not just the far plane, but a plane at any depth inside the frustum will be completely flat. This is the classic projection used by most games, but I think it feels a bit too flat. There are actually other types of projections, but they are very uncommon. Anyways, what this effect really is that we're faking another type of projection by bending these planes a little bit. I'll try to do just that in a vertex shader. It all starts with calculating the distance from the center of the screen, divided by depth. Here outputted straight into the color and alpha output. I'm thinking that I can just multiply the screen position x, y with the distance. Let's see. This doesn't feel far off, but it's kind of the opposite of what I expected. These pillars, for example, should be bending the opposite ways. Let's flip the plus to a minus and clamp the distance. And then make the distance exponential instead of linear. Okay, this is really trippy. I think the effect stops before the edges of the screen. I'll try to remove the top clamp. Nope, that wasn't it. Now the offset is becoming negative. Maybe I can zoom the effect in by multiplying the distance. Alright, this works. But now I'm getting these strange artifacts at the edge of the screen. Seems like some vertices are pushed so far into the frame that we're able to see them being culled. We should probably apply some compensation for this. The compensation could be calculated by taking the distance from the edge of the screen, I've used the value 1.5, and do the same calculations as for the current distance. This value can be subtracted from the final value. I'm pretty satisfied with the result. I think this looks better than the flat projection, so why isn't this common practice? Well, usually 3D rendering is done using polygons, where the edges are straight. This is something our classic rasterization techniques and GPUs are really good at. If the projection is flat, the edge remains straight. But now we've started bending the projection planes without being able to bend the mesh edges, which creates this strange look to surfaces that should otherwise be flat. Another issue with moving vertices in the vertex shader like this is that surfaces that are close together are more likely to clip and flicker. There are two workarounds for this issue, either a higher poly count or doing the effect in a post-process shader. The higher poly count is expensive and still suffers from the clipping issue. The screen space effect will make your pixel density vary between different parts of the screen, resulting in blurriness and other artifacts. Fortunately, our screens are becoming higher resolution, so it's less noticeable. I'm really curious on how Hyper Demon and Unrecord solve these issues. My guess is that Unrecord uses a post-process shader, but I have no idea about Hyper Demon. That game is crazy. For my game, I'll be trying out the vertex shader. There are some things I'm planning which makes the post-process shader impractical. Anyways, thanks for sticking around. and I hope you learned something. I will see you in the next video.